This is Cycle 1, Lesson 7. We're going to look at rational functions again, and we're going to in particular look at the reciprocal of a quadratic function. Last lesson, Lesson 6, we looked at reciprocal of a linear function, so a linear denominator. In this one, we're going to look at the reciprocal of a quadratic. So it's going to have a quadratic denominator, all right? Quadratic denominator. So we're going to analyze functions such as the one shown here. Something, whoops, supposed to be a highlighter. Something like this one shown here. In particular, what we're interested in is if it has a quadratic on the denominator. Because quadratics have possibly 0, 1, or 2 x-intercepts, that's important. Because remember, x-intercepts in the denominator give us a y value of 0 for any x-intercept, which means that we're going to have division by 0 for any of those that occur in the denominator. So it's going to give us more asymptotes, and it's going to make the graphing a little bit more complex, although not too bad as long as you get some basic rules down. So let's look at the first example, basic reciprocal of a quadratic function. So here's your basic quadratic function, your parent quadratic function, most basic one, is y equals x squared. So if we take the x squared and stick it on the denominator of a rational function, just take the reciprocal of it, then we get 1 over x squared. So let's do a table of values for this function. So if I stick -3 into this equation here, we get 1 over -3 times -3, because that's what x squared gives us. We multiply by itself, including the negative sign. So 1 over -3 times -3 is positive 9. So if I stick -3 into the equation, then I get 1/9 as my output y value, my f at x. If I stick -2 in there, then I'll have 1 over -2 times -2, which is 1/4. And -1 squared is positive 1, so I'll get 1 over 1. But that's just 1. Now, -1/2 squared, just so you can visualize it, remember, think about what we're doing. We're actually sticking, here, let's do it here. -0.5, we're sticking that into the function, which means we're doing 1 over -0.5 squared, which means 1 over -0.5 times -0.5. And -0.5 times -0.5 is positive 0.25. And if I have 1 divided by 0.25 or 1/4, I end up with 4. So my calculator would do all that work for me, but I just wanted to explain why, if we put -0.5 in, we're going to get 4 as our output. For 0, if I stick 0 in, I'm going to have 1 over 0 squared, which is still 0 on the denominator. So I have 1 over 0, which is undefined. And we saw last lesson that undefined gives us a vertical asymptote. If I put 0.5 in, well, 0.5 squared is also going to be 0.25, so I'm still going to get positive 4, and I'm going to get 1 over 1 for putting positive 1 in here. I'm going to get 1 over 4, and I'm going to get 1 over 9. You can confirm that if you want to pause the video and just, convince yourself that those are the correct outputs. So if we plot these points, here's what we get. Let's do it in red. So -3, 1/9, very close to the x-axis. -2, 1/4, slightly higher. -1, 1. And -0.5, 4. Then we have an asymptote. I'll sketch that in green. Hard to see it. It's there, though. If you look closely, squint a little. And then I have 0.54 and 1, 1 and 2, 1/4. And so it's like a mirror image in the y-axis. So again, what's the graph looking like? Well, if if I were to go farther out to the right, let's say, for example, I wanted to put negative 10 into my equation. When I square negative 10, when I stick it into the equation, I get positive 100. So I'd get positive 1/100th as my y value going along with negative 10. So I'm still going to have a positive value. It's going to be so close to the x-axis, I can't even do it justice touching it, or not touching it, but it is still above the x-axis. So I just do the best I can. I draw the line, and then it obviously curves up here. And then we have this asymptote at the y-axis, so it's going to keep getting closer to that without ever actually touching it. Okay? And then the same thing's going to happen on the other side. And so I'll draw it in a couple pieces like this, but I'm getting closer and closer to the y-axis, not touching it. I'm getting closer and closer to the x-axis here without touching it, in an ideal world anyway. So it should be getting, my graph doesn't really, my drawing doesn't really do it justice, but it should be looking like it's getting closer and closer to the x-axis. Let's just go to Desmos. Y equals 1 divided by x squared. And there's the graph, just like we drew it. So, what can we say about this graph? Well, it does have a horizontal asymptote. It's the x-axis. It keeps getting closer to that without touching it. So y equals 0 is our horizontal asymptote. The vertical asymptote is, I guess maybe just to be clear, let's say call it the x-axis. But the equation of the x-axis is y equals 0. The equation of the y-axis is x equals 0. X-intercepts, no, none. How can it have, well, I guess, never mind that. It has an asymptote, a horizontal asymptote on the x-axis. It has no x-intercepts. We can see it's never going to touch it. It can't have a y-intercept if it's never touching the y-axis. The domain is all real numbers except the y-axis. That's the only thing it can't touch. So again, we just have to have that one restriction. We can say that x is not able to equal 0, but everything else is fair game. As far as the range goes, looking at the graph, we can see that anything above the x-axis is going to be an output at some point. So it's all real numbers where y is greater than 0. Notice how I did not put that line there underneath the greater than sign. I put it there for a second, just draw your attention to it, but I've deleted it again. It should not have a greater than or equal to because it is not touching the x-axis. As x approaches positive infinity, as we go this way, what's happening? Well, as we go out to the right from the center of the graph, y is getting closer and closer to 0 from above. And as we go out this way towards negative infinity, y is also getting closer and closer to 0 from above. So we're thinking about, we're not reading it from left to right. In this case, we're reading it from the center outward to the right as it goes to positive infinity, and then we go back to the center and go, let's go out to the left as we go towards negative infinity, and that's how we read it for this kind of notation. The reciprocal of a quadratic function in factored form. So here is a quadratic. It's in factored form. As you can see, we're going to look at this one here. We're going to graph it on Desmos and then sketch our graph. So 1 over x minus 2 times x plus 1. So y equals x minus 2, bracket, x plus 1. All right, so we just stick that in here, and oh, look at this graph. That's kind of interesting, right? It does have some asymptotes. Let's start with the easiest one, the one that's familiar to us. It's got a horizontal asymptote again. It has two vertical asymptotes. And the vertical asymptotes appear to be at -1 and +2. Why would that be? Well, let's take a look at the denominator. Well, if you look at the denominator, you see you got x minus 2, which is going to give us a 0 of +2, and it's got x plus 1, which is going to give us a 0 of -1. But let's take a look at a graph of the denominator without, just as a quadratic, without being in the reciprocal of the quadratic. So I'm just typing it all in here. And lo and behold, there is my original quadratic in green, and then I've got the reciprocal of it in blue. Notice how, where the original crosses the x-axis, it's got y values of 0, which then gives us, when we divide by 0, undefined, which is then what gives us the vertical asymptotes at -1 and +2. And there's some interesting points going on here as well. If we look at this point by point, let's look at the vertex of this green one here. So the vertex is at 0.5 and -2.25. Let's look at the vertex of this chunk here, -0.444. Take your calculator and divide 1 by -2.25, and what you should get is -0.4444, because the reciprocal, again, is 1 over the function. But we could even do this point by point. So if I want to find the reciprocal of this point that I've got highlighted here, 0.5, -2.25, the reciprocal of that would be 0.5 and -0.444. It works on a point-by-point basis. Okay, let's graph it. Let's sketch it, that is. So, again, our vertices are at -1 and +2. Sorry, not vertices. My bad. Our asymptotes are at -1 and +2. Alright, so there's our vertical asymptotes I've sketched in there. And then we've got the horizontal asymptote, of course, I won't sketch in there because it's the x-axis. Then we had the two chunks, 3 chunks actually of the graph. There, the one chunk, I didn't really even talk about that, the actual graph, so I just talked about the asymptotes. But it went through these points here, sort of like this, and then another one up here, like this, again, to the best of my ability, trying to make it get as close to the asymptotes without touching them. And then it had, remember, at 0.5 and -0.44, something like that. There's our graph. Okay, let's quickly fill in the details. Domain is all real numbers, except where the asymptotes are. X cannot equal -1 or +2. The range is all real numbers, except the vertical asymptote. Actually, no, there's a bit more for that one. Sorry, I got to take that back. The range is all real numbers. Zoom in so I can write this neater. It's all real numbers, but there's actually a gap. So it doesn't touch the y-axis, right? So y has to be greater than 0. Or there's also this chunk down here, and that doesn't even go all the way up to 0, does it? In fact, there is a gap, and that gap runs from 0, what color do I want? From 0 all the way down to this point here. So if I can blow this up as big as it'll let me go, you can see there's a space I've highlighted in green. And again, it's not the most beautiful sketch, but remember we said that the highest point was supposed to be -0.4 repeating. So that is as high as it goes, and it has to be less than that. So it's either greater than 0 or y is less than or equal to -0.444. 4, 4. Now, was it repeating? I think it was repeating. Maybe it wasn't. Let's check again. I think it was repeating. So let's just say negative 0.4 repeating. So that's a little bit trickier. The vertical asymptotes, okay, they occur where the domain where it's not allowed, x is equal to negative 1, x is equal to positive 2. So there's two vertical asymptotes. The horizontal asymptote does occur at y is equal to 0. And that's it. Okay, let's do the next one. Negative 2 over x minus 1 squared, okay? There we have our graph. Interesting. Well, again, it looks like we got a vertical asymptote at positive 1, and that seems to correspond to the 0 of that denominator, x minus 1 squared. Let's look at the graph again of x minus 1 squared. Now there's some other things in this equation which might cause a little bit of confusion, but even if I were to throw in a negative 2 there, it should, there we go. You can see that the original function has got a 0 at positive 1, and that's where the reciprocal of it is going to have its vertical asymptote. So we'll get rid of that and just sketch this graph that we have, what we have left. Positive 1 vertical asymptote, and horizontal asymptote, you may have noticed, was the x-axis, but it only had 2 chunks for this graph because there was only 2 asymptotes, 2 vertical, sorry, shouldn't draw and talk at the same time. It only has 1 vertical asymptote. So it's going to look like this. Again, it's a rough sketch, but you get the idea. So 1 vertical asymptote, 2 chunks to the graph. 2 vertical asymptotes, 3 chunks to the graph. Domain, all real numbers except the vertical asymptote, which was positive 1. Range, all real numbers. Now this gets closer and closer to the x-axis without ever touching it. You really have to look at the graph to get the range for these ones. Y is a member of the set of real numbers, and it has to be less than 0. That's all we have to say about that one. There is no above the x-axis for this one. Vertical asymptote, positive 1. Horizontal asymptote, 0. Okay, let's look at a couple that are in standard form. Graph the functions on Desmos and sketch them below. Then we're going to factor them so we can see what connections there are. So it was 2 over x squared plus 3x plus 2. Okay, and so let's just recenter that. You can see there's actually 3 chunks to this graph. Maybe if I zoom out a bit, zoom out a bit, you can see it better. There is that one that starts way down. It looks like at about -8, about 1.5 to -8, something like that. Well, I can find it out by just, there we go. Oh, that's a pretty good guess. 1.5, -1.5, -8. All right. And then there's the 2 chunks up above. Again, 3 pieces to this graph because it's clearly got 2 vertical asymptotes. What are those vertical asymptotes? They appear to be at -2 and -1, just from looking at this graph. Well, let's sketch the graph based on this. So let's sketch it first. -2, another one at -1. And we had the piece of the graph again. It seems that we've got the x-axis as a horizontal asymptote. We've got another piece over here. And then we've got this chunk down here that we saw was at -1.5, -8. So just that little piece down there. Okay, so then we're supposed to factor each denominator. All right. So 2 over, what are the factors of x squared plus 3x plus 2? So two things that multiply to give 2 and add to give 3. So plus 2, plus 1. Oh my goodness. Look at that. We got zeros on the denominator of -2, -1. That corresponds to the vertical asymptotes of x equals -2 and -1. So we can see that whether something's in factored form or standard form, the graphs should look the same, and we still get the same asymptotes, and so on. So let's graph this one, 2 over x squared minus 4. Since we've already got part of this here, maybe I'll just erase a little. And that is what we've got here. Vertical asymptotes at -2 and +2 in this case. Does that make sense to you? Can you see why? Before I graph it, let's factor it and see if we can explain why. X squared minus 4 is a difference of squares with factors of x plus 2 and x minus 2. That would explain why we have vertical asymptotes at -2 and +2. Horizontal asymptote on the x-axis. And then we had that little chunk below. Let's try to be a little bit accurate and see where it was. So it goes at -0.5 was how high it came up. So I like to be accurate when I can. So that would be here. Again, this is one, well, both of these are ones where the range would be kind of funny. The range for both of these would be any values of greater than 0, but we would have to find the vertex of that downward facing U shape in each part for the cutoff for that lower part of the range. But they don't ask us to write it, so we won't. Last example, reciprocal of a quadratic function if there's no real roots in the denominator. What are we talking about? Well, remember, not every quadratic has real roots. So let's actually just look at the denominator to start with. X squared plus 4. Factor that. We can't, right? We can't factor that. Why can't we factor that? Well, there's no two things that multiply to give 4 and add to give 0. So what does a graph look like? Just of y equals x squared plus 4. Ah, well, there we go, right? The reason why we can't factor it is because y equals x squared plus 4 doesn't cross the x-axis. There are no zeros for this. So then what happens if we put it as a reciprocal of that? 1 over x squared plus 4. We get this weird thing going on here where we have no vertical asymptotes. We just have this little blip, and then it goes down. We do have the horizontal asymptote. And again, remember, we're doing a reciprocal here. So if I take the reciprocal point by point of this blue graph, take the reciprocal of the y value of this. I have 4 as my y value of the vertex. Well, what's the highest point here? 0.25. 0.25 is 1 over 4. It's the reciprocal of 4. So that's where the 0.25 comes from. And then if I find any point I want, so let's say I go to guess it's hard for me to see it here to be really precise, but you know, we got this point here at 1, 5, okay? So if I take the reciprocal of the 5, I should have a point on the green graph of 1 and 0.2. There it is, 1 and 0.2, if you saw it just for a second there. So point by point, we've got the reciprocals. So it comes up only as high as 0.25. So this is going to be a very uninteresting looking graph, or at least as far as a lot of movement goes. It's going to sort of go like this. Just a little bump, but it has to stay above the x-axis. And it's identical on this side. I'm not doing a great job of getting close to the x-axis, but that's just my, that's just my humanness of not being able to draw it exactly precisely. But what I want you to notice is there is a little bit of a bump there in the middle. What's the domain? All real numbers. There are no vertical asymptotes. There's no restrictions. The range is very strange, in fact. I'm a poet. The range only goes as high as 0.25, and it goes as low as the x-axis, but it doesn't touch the x-axis, so it's all real numbers. In fact, let me give myself a little more room for my restriction. I'll back it up a bit. Y is all real numbers, but it's between 0 as my lowest point. It's got to be greater than 0, can't include 0, and it's got to be less than or equal to 0.25. We saw that was the highest that the range went. Vertical asymptotes, none, right? No vertical asymptotes. Horizontal asymptote, yes. Y equals 0. Some key concepts. Read those over for a nice